Okay, so question 5. In a shooting competition, Louise has an 80% chance of hitting her target and KO has a 90% chance of hitting her target. If they both have a single shot, determine the probability that, and we'll look at those. Now, just as a reminder, remember the probability scale works from 0 to 1, where 0 is no chance and 1 is a definite chance. Now, when it says 80%, 80% means 80 over 100. This percent sign basically means that. So that's 0.8. So on this probability scale, then Louise is about over there at 0.8. KO would be about over there at 0.9 probability. So both hitting their targets. Now, we could draw this up as a tree diagram, and perhaps it would be a good way to do that. Firstly, looking at KO. Actually, let's do it as it comes in. Let's do Louise first. And to hit and to miss, it's 0.8, and then obviously 0.2 to miss. And then for KO, when she goes up, it would be 0.9 and 0.1 to hit and miss, hit and miss, 0.9, 0.1. So to both hit their target, there would be along there. So the probability of a hit would be 0.8 times 0.9, which would be 0.72. Neither hits their target would be this one, 0.2 times 0.1, so the probability of a miss would equal 0.2 times 0.1, which would be 0.02. At least one hit their target. Now, at least means that we have got the situation where there could be two. They could both hit it. So those routes would be, let's do it in green this time. It would be a hit, a hit, miss. That would be at least one. A miss, hit. So it's all the routes except for this final one of a miss. So the probability that at least one hit would actually be 1 minus 0.02, which is equal to 0.98. And then only KO hits her target. That would be that Louise misses hers and KO hits hers. So the probability that only KO hits is equal to 0.2 times 0.9, which is equal to 0.18. Okay, so it's important to, sometimes we write probabilities and percentages. It's important that you can take it down to the decimal place. Fine, going on to this next question here. We have two fair six-sided dice are rolled simultaneously. Determine the probability that the result is a double. Now, just very briefly, we can draw up a probability space. I won't do the whole thing. I'll just do a few. I think you'll see the pattern. But we've got probability space for this would be like that. So our doubles would be these: 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. So there's actually 6 possible doubles, and obviously there's a total of 36 different possibilities. If I go through all of these, and you'll see that's a total of 36. So the probability of getting a double is going to be 6 over 36, which is equal to 1 over 6. Okay. Going on to question 7. It says a bag contains 4 green and 3 red marbles. 2 marbles are randomly selected from the bag, the first being replaced before the second is drawn. This would be an example of an independent event. Find if they're both green or if they have a different color. So let's draw up the tree diagram. We've got the first event, the first marble being taken out. It could be a green or a red. And then we have the second one taken out. Could be a green or a red, green or a red. Now we've got a total of there goes the bell. There's a total of 7 marbles, so it's 4 out of 7 and 3 out of 7. Now, because the first being replaced, this is important. That means that whatever you pick out, you put it back in, so there remain 7 in the bag. So this probability will again be 4 out of 7, 3 out of 7. 4 out of 7, 3 out of 7. What you pick in the first one, in the first event, and the second, it doesn't affect the second event. So both green would be there. The probability that you're going to have a green and a green is going to equal 4 out of 7 times 4 out of 7, which is equal to 16 out of 49. And the probability that they are different in color, the probability of different colors. Alright, so it will be this route over here. You'd get a green and a red. So that's going to be 4 out of 7 times 3 out of 7 plus, now we've got another route, so it's going to be a red and a green. 3 out of 7 times 4 out of 7. So we're going to get 12 over 49 plus 12 over 49, and because the denominators are the same, we can just add those, and it's going to be 24 out of 49. Okay, good. I think we'll leave it there, and then I'll do the